Okay, guys, so I hope you still have some energy. I know it's late, but my talk actually will be really short. By the way, I'm Mateusz, not Łukasz. Thanks, Szymon. We only work like for a year and a half, but that's okay. You don't remember my name. Okay, so let's get started. Maybe let's start with a question. How many of you actually know this concept of a data frame from R, Python, Spark, whatever? Okay, so I'll try to tell the other guys what it is. So basically, you can think of it as some kind of abstraction for working with structured or semi-structured data. If you know relational databases and the concept of a table within this database, so that's basically it. So this is like kind of structured data where you have rows, where each column is has some kind of type and name, and it. Sorry guys, but you. Yeah, so basically tabular data when you have rows and columns and data is structured in this kind of way. And this is some abstraction for us to work with this kind of data, and we expect the framework which supports this kind of thing to do several things. So first of all, we want to read and parse data in many different formats. We don't care if it's a CSV, it's Excel, it's whatever. We just want to like load it, and it's already there for us, and we can work on that. And we want to manipulate this data. So basically slice it, sort, group by some key and aggregate, compute some statistics, do some transformations, so map some column, for example, or merge two columns together, and join different data frames. So basically, if you know SQL and all of those group by and aggregations, count sums and stuff like that. So this is basically the very similar approach for working with data, and we want that, but in more powerful API, which is a full programming language. And yeah, we can do much more with that. And of course, at the end, we want to export the final data set, as some other format. So here's one example of a Python data frame. So I basically use pandas library to read CSV file. And this is some bank data. So I have data about bank customers with their age, job, marital status, stuff like that, right? And now I can do something useful with the data. So for example, take a subset of columns and rows, and yeah, more sophisticated stuff. So basically, I filter the housing only for values where we have yes. I group by marital, and I basically aggregate the balance. I want to compute the mean balance based on marital status, right? And yeah, this is it. So this is the aggregate. We can see that single people have more money. Okay, so I'm not going into detail of Python data frames because I basically did a previous talk on the previous data crack last time, so you can check that if you want. I actually presented, the whole Python ecosystem for working with data, and now we'll focus on Spark. So, yeah, as Szymon presented Spark for you, it's awesome already. So Spark started, several years ago with simple API of key value tuples, similar to MapReduce framework, for distributed data processing. But as Spark continues to grow, and there are more people coming, and this simple API is already stable, we want something more. We want a richer API, more powerful. And this concept of data frame is really tempting because it's really nice declarative way of working with data. And if we could apply this to distributed data, large data, it would be super awesome. So actually, Spark introduced a few months ago new DataFrames API created with this goal in mind. It's very similar to R and Python, but designed there are some differences. It was designed from ground up to be better and support big data and modern applications. So some of the features, of course, they are distributed, so you can actually load terabytes of data as data frames, which are distributed on different machines. And as Spark is designed, they are lazily evaluated. So each operation, like this group by, map, aggregation, stuff like that, creates a kind of logical plan of execution, which is then, in the end, when you want to save it or do the final aggregation or collecting the data, it's mapped to a physical execution plan. And it's super sophisticated because it actually uses code generation, like sophisticated optimizer to generate the best plan to execute this kind of grouping and aggregating you want to do. So, but the functionality is very similar to Pandas DataFrames, and they are really fast. So this is like some slide from Databricks. As you can see, Spark DataFrames are much faster than RDDs, and it doesn't matter if it's Scala or Python, because this is like I said, this is the kind of abstract plan of execution, which is then like mapped to physical plan using code generation. So really powerful stuff. So let's try it in practice. And we're already on Hadoop cluster. And to show you that I'm not kidding, although Shimon already did that, but we actually have a 16-node cluster. And let's create a Spark context for that. So here I want 8 executors, 4 gigs RAM, each executor. So it's not too much, but it will be enough for our example. And let's do a real-life example. So we'll actually use real-life, like real-based data for this, and we want to calculate percentage of engaged users. So yeah, we load base interactions data from web frontend, so basically how people use our frontend. And for like a given day, for yesterday, we'll calculate what is the percentage of engaged user, and we'll have some definition of engaged user, and we'll use Spark DataFrames for that. So first, let's see what is the schema. So let me execute this code. So I basically load from some data on S3. I load Avro file with web interactions from yesterday. And as you can see, it executed immediately because it actually just loads the first file in that directory to get the schema. And yeah, so we have the most important things for us are this user ID thing and timestamp, because we want to like calculate what was the time when the user was active, right? So let's attack this problem. Let's assemble the plan, and we'll use a very simple thing. So basically, the first step will be to map each timestamp to hour, right? So I don't know what is the hour, but about 9 p.m. or so. So basically, we'll map like timestamp from now to 21, right? This is the goal. And we'll assume that if a person clicked in a given hour, he was active for that hour, okay? So just one click. This is the simplification, but that's fine for us. And then we'll count distinct hours for each user, right? So if a user clicked at least once 9 p.m. and 10 p.m., then he was active in a given day for 2 hours, right? And our definition of engaged user is user who was active for at least 4 hours, right? And then we'll compute the ratio of engaged users versus all users. Okay, so let's do that. First step, we map the timestamp to hour, right? So we create this simple lambda function which takes timestamp and parse it to datetime, basically. This is like a datetime object from Python. And once we have that, we can extract the hour, right? And this is, the normal Python lambda. And with this UDF wrapper, we can map it to like PySpark UDF, which we then can apply on a column. So we take our interactions, we add new column called hour, and we apply this hour UDF on timestamp field, which is like nested in the data field, right? So once we execute that, you can again see that it executes immediately. So this is like added to as a lazy evaluated step to our plan, and we have this new hour column. Okay, so next step, this is like almost the final step, because first we do the filtering. So we extract only those, this is like a where clause, right? So we extract only those interactions where the type is click, to get rid of other types like errors or syncs or stuff like that. Then we group by data user ID, and we count distinct hours, right? You will see that we don't have this grouping key actually. So this is a small bug. It's fixed in the next version, but we don't care because we only want to count we only want to count how many users were active more than 4 hours, right? So this is fine for us. And yeah, so this is the final step. We want to basically find engaged users. So again, filter by discount and only select those who are active more than for more than 4 hours. And like divide this by total user activity. So let me execute this. It will execute for about 40 seconds. This is also an important step because I actually, in order to compute this, I need to do a one pass through this execution plan, and this is the second step, right? So in order to avoid computing whole thing from scratch again, I just cached this data frame before actually, this computation, and this allows me to, the first time I compute this, then it's cached and stored in the memory, and the second run will be much faster. So yeah, so now it distributed this work on multiple workers on the cluster, and eventually we'll have the answer. So about 42% of our users are engaged and are using Base more than 4 hours a day for this given day. Okay, so yeah, so let's try to compare Pandas and Spark. So Spark data frames are still experimental and quite raw, which means the API is not super sophisticated. Plus, there are some nasty quirks. Let me show you an example. So let's do a join between two data frames. So this is a simple Pandas code for data frames, right? I just created two of them with first has A-B columns and second has A, B, and C. And if I merge those two, this is what you get, right? So because I joined on A, it's a left join, and because there were two B columns in first and the second data frame, it added those nice suffixes, and I have those nonce where there was no data in the second data frame, right? And let's do something similar in Spark. So here I create a distributed data frame in Spark from those local data frames. So the schema is what you expected, but now when we try to join this is something weird, right? We have two A columns, two B columns, and a C. So let's try to actually collect this. And it's not what we expected. It's total garbage. So basically, the first row is completely wiped out, and the second one, there were no prefixes added, and actually, only one value of the variable is kept. And those are, some quirks that you will bump into when you use Spark data frames. So we actually started developing a library which adds some sugar to Spark data frames and more makes them more similar to Pandas, and it's totally doable. So yeah, so let me just load some of our internal code. And this is again, those are also Spark data frames, so XS, YS, but now I have the same API as in Pandas for merging this data on some column. Schema is exactly the same as after merge in Pandas. And if I collect this data, this is what we expected, right? So there are suffixes added, and there are values on proper places. So yeah, so sometimes we need to write some additional code to make it work, but overall it is great because first of all, this abstraction itself, a data frame, is super powerful because it's mixed between real code and SQL-like declarative language, right? So you tell that you want to group data, but you don't actually code the whole grouping. But on the other hand, you can write regular code to, for example, parse a timestamp as we did and map it to hour, right? So this is the perfect mix of those two worlds. And because you were able to see that we actually use the same environment for working with data. So regardless of the size of the data, whether it's small data and can sit a single machine, we can launch a notebook, use Pandas for data analysis. And if we have lots of data, we can launch a notebook again and have almost the same environment for working with big data using Hadoop cluster and Spark data frames. And actually, if we do a little bit of more work, then we can actually take these nicer Pandas-like APIs and create, like map it to Spark stuff. Yeah, so that's it. Thanks. Questions?
Do you know if the sklearn library, the library for Python to do the machine learning, will support the DataFrames or not?
No, because scikit-learn is implemented totally locally. It's using Cython, for example, right? And it's optimized for NumPy, stuff like that. So we have two options for machine learning on Spark. First is, actually there are more, but first the main one is just MLlib, like officially supported by Spark. But there is also a library called Sparkit-learn. I didn't use it, but it actually tries to do similar thing what we did with DataFrames in this example, right? So it kind of like mimics the scikit-learn API on top of Spark. Okay, so thanks guys.